Alright, this is section 7.6 on variation in your text. Basically, here's a definition of variation. Y varies as x. If there is any, change this pointer to red. Okay, so y varies directly as x. If there is any real number k such that y equals kx. Okay. Y is said to be proportional to x. Basically, k is called the constant of variation. I think that probably should have been bolded, but basically k is called the constant of variation. So if you can write it in this form and k is some constant, basically y varies, x varies, but x and k is constant, which is why it's called the constant of variation. So pretty much all there is to that. So our first example, it says let the Eva Lushman is paid an hourly wage, so we can call that W. So she paid an hourly wage. We just call that W, wage. All right. So 1 week she worked 43 hours, all right, and was paid $79.50. All right. So how much did she earn per hour? Well, if you want to know your total pay, it's going to be the number of hours you work times the wage you make, basically. And let me not use H. I'm going to use T for time, um, because it might get confusing. Because actually, the standard abbreviation for hour is H, so that might be a little confusing. Kind of like using B for bolts, which is done very often, but maybe a little confusing. Pointer options. Okay, so basically, P equals your pay, your total pay. W equals your wage, rate of pay, basically. And T equals time worked. So basically, my constant of variation here. So let's see here. So what varies? Basically, your constant is going to be what doesn't vary. So your pay depends on the amount of time you work. Your wage is fixed. So basically, this is your constant of variation. So basically, you have, if I want to figure out what that is, they give me a pay is 79.50. Give me a pay. They also give me a number of hours. So T equals 43 hours. So basically, what I end up with is, so if I solve for W, I end up with W equals P over T. Well, so my pay is 79.50 over 43 hours. Which is basically going to be $18.50 an hour. So now I can rewrite this with the given information. So I can write P equals 18.50 T. And in this case, they want to know what happens when T, oh, actually, this is all they're asked for. You want to know how much she gets paid an hour. This is actually all the question asks for. The book takes a little bit further. They kind of go ahead and if you set it up like this, you can figure out the pay for any number of hours basically, because you have a constant variation. Your pay rate times your time will give you any pay basically, any amount of work, amount of pay for the week. Right? But basically, for what they're asked, this is your final answer. I guess I didn't need that many slides. Kind of overdid it. All right. So in example 2, here they're talking about Hooke's law. So basically, according to Hooke's law, for an elastic spring, and elastic means it stretches and compresses. It doesn't mean it's made of that polymer rubber material. A metal elastic spring is usually going to be a metal. It just means it has elasticity. All right. Okay, so the distance the spring stretches, okay, we can call that D, is directly proportional to the let's just say 2. So it's directly proportional to the force applied. So we'll call the force F. So we'll just call it force F. Alright, so basically we have D equals, let's see here. Yeah, so D equals K F. Kind of opposite of what I'm used to seeing. You usually see is F equals K times X or K times D or whatever, but here they flipped it around, which is all fine. Usually they have F equals, usually you're looking for the force in terms of the distance traveled, but they reversed it here for this problem, which is unusual, very unusual. But at any rate, so basically, what do they tell us? Let's see here. A force of 150 newtons. So 150 newtons stretches the spring 8 centimeters. So force of 180 newtons. So let's see here. K, we want to find our spring constant. Well, not, excuse me. Written like this is not a spring constant. Sorry about that. We just want to find, K. All right. So if it was written the way I had up here, it would actually be called the spring constant. But since they reversed it, it's not the spring constant anymore. So basically what we have is K equals D over F, which is the distance is 8 centimeters. The force is 150. So basically we have we end up with 4 centimeters over 75 newtons, or 4 over 75 centimeters per newton, however you want to write that. But basically we're looking for this, the 4 over 75. It's the main thing we need. All right, so now we can put that back in here. So we have D equals 4 over 75 times your force, and your force is 400 newtons. So 400, which is actually going to end up giving you 64 over 3. Centimeters, or 21 1/3 centimeters. Both of those are acceptable. The second one is probably going to be more useful, and even more useful will be a decimal. And the next thing, direct variation as a power. Basically, the same thing, except for now, your x is raised to the nth power and multiplied by k to get your y, basically. So you say that y varies directly as the nth power of x. Right. And the examples the book uses seem to limit it to the second power of the square. So basically, let's see here. So we have y equals k x to the n. Is basically what you have. That's the form. So let's see here. The distance a body travels. So we'll call that d. Varies directly as the square. So basically that means n equals 2 of the time it falls. We'll call that t. So basically we have d equals some constant times t to the n. So that's what we basically have. Or we could have called it y and x, but I like to try to give the variables meaningful symbols so that we can actually remember what the stuff stands for. It says a skydiver falls 64 feet in 2 seconds. So we got to solve for k first. So we have d over t to the n equals 64 feet over 8 seconds squared, which is going to be 16 feet per second squared. Right. So basically the 16. So here we want to find how far she will fall in 8 seconds. So d equals 16 times 8 squared, which is going to be 1024. That's feet. And paranoia, make sure this thing is actually recording. Darn it. Lost my page. Not recorder. Pretty sure it is. Yeah, it's recording. Okay. I always get paranoid and think it hasn't been recording. I gotta start over. Alright, so I'm actually recording. Good. Slideshow. Current slide. Okay. Alright, and our next example. Inverse variation. So inverse variation, basically you probably heard the phrase inversely proportional, basically the same thing. So y varies inversely as x if there is a real number k such that this is true. Y varies inversely as the nth power of x if this happens. Same thing except for it's k over the variable instead of k times a variable. So that's what the inversely is. So, so basically, as you can see, as one goes up, the other goes here. When y or when x increases, y increases. If I put a bigger x, I'm going to get a bigger y. If I put a smaller x, I'm going to get a smaller y. And the same thing for here. X increases, y increases, x decreases, y decreases. So that's why it's called directly proportional, because the relationship is direct. They both increase. When you increase one, you have to increase the other. And when you decrease one, it forces you to decrease the other. Well, here, inversely proportional, if I have x, if I put in a bigger x, I'm dividing by a bigger number, so y is going to get smaller. If I make x smaller, that's going to cause y to get bigger, because I'm decreasing the number I'm dividing by. Basically, you're getting rid of the people you got to share with when you're dividing by a smaller and smaller number, so you're going to have more for each person. And same thing can be said for here. Alright, so example 4 says the manufacturer of a certain medical syringe, in the manufacturer, the cost of producing a syringe varies. So cost, we'll call that C, varies inversely as the number produced. So basically, this is saying that as you produce more, they let you get a discount for buying in bulk. Basically, that's why the cost decreases as you buy more. So we can call this. I was going to use N, but I guess that might be confusing. I'll just call the number produced. The number produced. We'll call that Q for quantity. And C equals cost. Alright. So basically, what we end up having is, let's see here. So they say we got, so if 1,000 syringes are produced, so here our quantity equals, well, actually, before I go there, let me erase something. Okay. So if the number, let's see here, so 10,000 produced. Okay, so basically it's saying that Q, or not Q, Q this way. Q, or cost, excuse me, equals K over Q, basically. So it's inversely proportional with Q. The cost is inversely proportional to the quantity, basically. So from that, if I want to figure out K, that's going to be CQ, which is going to be a cost of $2. $2 a syringe times 10,000 syringes is just going to be whoa. Wait a minute. K equals CQ. $2. Sorry. I'll just drop these units. That might be confusing. Let me drop the units. Not even gonna worry about the units. So erase all these units. Just put the numbers. Okay. Okay, so it's just going to be $2 per syringe. Because here, C1 equals $2, and Q1 is 10,000 syringes. So basically, we have 2 times 10,000, which is just 20,000. So now we have our K. So now we can write C equals 20,000 over Q. And in this case, our Q for the second one. So for Q, when the quantity is 25,000, that's going to be 20,000 over 25,000, which is basically which is basically 80 cents. Alright, so this example talks about an orbit, a space shuttle orbiting. You basically have Earth, and it's making an elliptical orbit, so you have supposed to be an ellipse, but things not easy to draw with. Alright, so, but basically you just have this space shuttle that's moving around this thing. Doesn't matter if which direction it's moving, but the point is it's orbiting the Earth like this. Okay, so these are 2 points. This is the center of Earth. So basically, change colors here. So basically, in the image in the book, they call this D2, and they call this D1. Okay. So, but basically, alright, so let's write down the information we're given. So they say that the change back to red so we have some contrast here. Alright, so it says the weight, and we'll call weight W, weight of an object above the Earth varies inversely as a square, so it's going to be W equals K over, let's see here, something squared. Distance, call that D. So it says a spatial elliptical orbit, as I've drawn in the figure on the next page. They say the distance at apogee. Okay, so this, they call this point apogee, which is perigee. All right, so but basically, so it says the astronaut in the shuttle weighs 57 pounds. So the first weight is 57 pounds at apogee, which is, let's see, D1 is 6,700 miles, or 6,700 miles. And of course D2 so we have that basically K equals all right, WD squared, which is 57 pounds, times distance D1, so it's basically going to be W1 D1 squared. So we have 6,700 miles squared, and this, yeah, the calculator might have a problem with that. Yeah, I mean, your calculator, if you have a simple one, it may just output it as in exponential form or in scientific notation. It's okay to for this case, we can leave it like this for now because we're not really asked for the constant of variation. That's not what we're asked for. So we're just using that for an intermediate calculation. What we want to know is what does the astronaut weigh at pedigree. So at pedigree, we basically going to have, so let's rewrite our equation. So weight equals K, which is 57 times 6,700 squared over distance squared. What did I do? Wait a minute. I think I wrote something wrong. Flipping back and forth. Your weight is K. Oh, okay, that's right. Over distance squared, which is D2, which is this is the distance we're interested in right here. So 4,090. And if you divide that out, it ends up being 152.96 pounds. And I think the book rounds to 153 pounds, but and also you don't have to just vary with one variable. Most of the time things have more than one thing affecting them. Almost all the time they do. So you can say that y varies jointly as x, And again, I should have bolded this, but basically, y varies jointly as x if there exists a real number k such that this holds. So let's look at the last one, multiple. All right, take a short break.